At 31,600 kilometers from Earth, Asteroid Apophis will skim closer to us than our own satellites, on Friday the 13th, no less. When scientists calculated that this massive space rock once carried a 2.7% chance of slamming straight into our planet, a risk level never seen before, panic rippled through the world's observatories. Some call it a fascinating cosmic opportunity. Others, haunted by history, whisper its true name, the god of chaos. Because what terrifies the experts isn't just Apophis's next encounter, it's what could happen after. If we've only dodged disaster by a cosmic hair before, what are the real odds that this time humanity won't? On December 24, 2004, the numbers on the screens at NASA's Jet Propulsion Laboratory refused to budge. Apophis, catalogued just 6 months earlier at Kitt Peak by Tholen, Tucker, and Bernardi, was now the most talked-about rock in the solar system. Each new orbit calculation fed into the Century Risk Table brought a fresh spike of adrenaline. By late afternoon, the probability reached 2.7%. No asteroid in recorded history had ever shown odds like this. That figure meant out of every 40 Christmases, one could end in planetary disaster. David Tholen described waking to hundreds of emails, the tone shifting from curiosity to outright panic. Paul Chodas and Steve Chesley recalled sweaty palms in the control room as the world's media began to call, demanding answers no one could give. At Kitt Peak, the Discovery team abandoned holiday plans, combing through photographic archives and sending hourly updates. The Minor Planet Center's database logged frantic requests for old sky survey plates, anything that could clarify Apophis's path. Inside NASA, the mood was electric and grim. Internal memos from the Near-Earth Object Program show a relentless, minute-by-minute review. The Torino Impact Hazard Scale, designed to calm the public, had just been breached. Apophis was now a level 4, the only asteroid ever to reach that threshold. As the sun set on Christmas Eve, there was no relief. The only certainty was the uncertainty itself. The next calculation could bring the risk down or push it higher. Through that long night, Tholen, Tucker, and Bernardi watched the data, knowing that every decimal point could mean the difference between a close call and catastrophe. The world's fate for a few sleepless hours seemed to rest on a handful of numbers, and the hope that somewhere, in the stacks of forgotten sky images, a faint trace of Apophis might change everything. Apophis carries a name that is anything but comforting. In ancient Egyptian myth, Apophis was the serpent of chaos, a cosmic force that battled the sun god Ra every night, threatening to plunge the world into darkness. Naming a near-Earth asteroid after this destroyer was no accident. The symbolism is hard to ignore, especially when history offers its own reminders of chaos from above. On the morning of June 30th, 1908, a fireball streaked over the remote forests of Tunguska, Siberia. Without warning, an object, no more than 60 meters wide, exploded in the atmosphere, flattening 2,000 square kilometers of forest. The blast was so powerful it knocked people off their feet 60 kilometers away and registered on barometers around the world. No crater was found, only scorched earth and millions of fallen trees radiating from a single point. For decades, the cause remained a mystery, but today scientists agree it was an asteroid or comet smaller than Apophis, yet strong enough to erase a city in a single instant. Fast forward to February 15th, 2013, over Chelyabinsk, Russia, a 20-meter asteroid entered Earth's atmosphere at more than 19 kilometers per second. The shockwave shattered windows across 6 cities and injured over 1,500 people. Security cameras captured the blinding flash as it streaked across the morning sky, a reminder that even modest space rocks can unleash chaos with no warning at all. These are not stories from ancient myth. They are modern events, real impacts, witnessed by people living now, each one a warning. The difference between a cosmic close call and catastrophe comes down to size, speed, and luck. And Apophis, at over 370 meters wide, dwarfs both Tunguska and Chelyabinsk by orders of magnitude. The name, the history, the science, they all point to a single, unsettling truth. The universe is not a peaceful place. The next encounter with Apophis will not be just another flyby. It will be a test, a confrontation with chaos, written in both myth and memory. On April 13th to 29, Apophis will thread a path through Earth's backyard that no asteroid its size has ever taken in recorded human history. The numbers are almost impossible to believe. 31,600 kilometers from the planet's surface, closer than most of the satellites powering global communications, weather, and navigation. For a brief window, this 370-meter wide asteroid will be traveling inside the ring of geostationary satellites, crossing a zone crowded with the machinery of modern life. Astronomers have calculated that Apophis will reach a magnitude of 3.1, making it visible to the naked eye in dark sky regions. In cities, binoculars will be enough. For millions across Europe, Africa, and Asia, the asteroid will appear as a moving star, tracing a path of more than 200 degrees across the sky in just a few hours. It will be brighter than any asteroid path since the dawn of civilization, outshining all but the most brilliant planets. Tracking teams around the world are preparing for an observation campaign on a scale never attempted before. Telescopes from Hawaii to South Africa will lock onto Apophis as it races across the sky at nearly 8 kilometers per second. Space agencies are scheduling radar campaigns, hoping to measure its position to within a handful of meters. Even amateur astronomers are gearing up, some already calling it the asteroid eclipse, but the spectacle hides an undercurrent of anxiety. The closeness of this pass means that even tiny uncertainties, fractions of a degree, milliseconds in timing, could have consequences decades down the line. The asteroid's trajectory will be bent by Earth's gravity, and the exact outcome depends on details almost too fine to measure. Every new observation narrows the margin of error, but the need for precision has never been higher. For one night, humanity will look up and see a cosmic bullet whiz past, close enough to unsettle even the most hardened scientists. The world will witness a natural event that until now belonged only to computer models and disaster simulations. And as Apophis slips through the satellite belt, the question will linger: just how close is close enough when the fate of the future hangs on numbers this small? Earth's gravity is not a silent bystander during the Apophis flyby. As the asteroid races past at 6 kilometers per second, tidal forces reach across space, pulling at every loose boulder and dust grain. For planetary dynamicists, this is a rare chance to watch a cosmic experiment unfold in real time. Simulations run by geophysicists at NASA and the European Space Agency suggest that as Apophis flies through the planet's gravitational well, its speed will surge to 7.4 kilometers per second, an instant acceleration of nearly 25%. But it's not just the orbit that changes. The asteroid's spin, already complex and tumbling, will be subtly tweaked. Models predict a measurable shift in its rotation period, the kind of change that could only happen under the strain of a close planetary encounter. On the surface, the stress is even more dramatic. Tidal simulations show that slopes near the asteroid's equator could shift by several degrees, just enough to trigger landslides or send pebbles drifting into space. These aren't catastrophic quakes, but the fingerprints of Earth's influence, tiny avalanches, fresh scars, and maybe even a brief cloud of dust trailing Apophis as it departs. For a rubble pile asteroid loosely held together by its own weak gravity, these moments are transformative. The asteroid's shape, its spin, even its future path, each is being rewritten by Earth's invisible hand. Observatories will be watching for sudden flashes of reflected sunlight, hunting for evidence of regoliths sliding or new debris clouds. The asteroid's surface may brighten, its spectrum shifting as fresh material is exposed. Every new measurement feeds into the orbit calculations, tightening predictions for where Apophis will travel next. Yet with every nudge and quake, a new uncertainty is born. Small changes in velocity or spin, measured in millimeters per second, can compound over years, nudging Apophis ever so slightly off its predicted course. For scientists tracking the aftermath, the real tension lies in the unknowns. How much will Earth's gravity change Apophis's future? Will a landslide or a sudden spin shift send it drifting closer to a cosmic trapdoor? The answers are buried in the data, waiting for the moment when the asteroid's fate, and ours, could pivot on the tiniest of shifts. Imagine a corridor in space, barely 600 meters wide, less than the length of 7 football fields. This is the infamous gravitational keyhole, a razor-thin slot carved into the mathematics of Apophis's 2029 flyby. If the asteroid were to pass through this invisible window, Earth's gravity would nudge its path just enough to set up a future collision, potentially in 2036 or decades beyond. The odds of threading such a needle are almost laughably small, but the consequences are anything but. On the so-called B-plane, a geometric map perpendicular to Apophis's incoming speed, scientists plot every possible trajectory, each line representing a future that branches in and out of danger. The keyhole is not a gaping doorway, but a threadbare slit demanding millimetre-level accuracy in both observation and prediction. Even the tiniest change, a pebble sliding on Apophis's surface, a faint push from sunlight, a micrometeorite strike, could spell the difference between a harmless pass and a date with disaster. Dynamicists pore over resonance calculations, searching for any scenario where Apophis's orbit might sync with Earth's years later. The numbers are merciless. To hit the 2036 keyhole, the asteroid would need to shift by more than a kilometre, far beyond current projections, yet the 2068 window, though hundreds of times wider, still sits thousands of kilometres from Apophis's predicted path. Each new radar campaign shrinks the uncertainty, tightening the funnel of fate. The reality is both comforting and chilling. The cosmic trapdoor exists, but Apophis is not aimed at it. Still, the margin for error remains vanishingly thin. For planetary defense experts, the lesson is clear. In celestial mechanics, the difference between safety and catastrophe can be measured in meters, or even less. One stray calculation, one unaccounted for nudge, and the odds could change overnight. If Apophis were to strike, the numbers defy imagination. A direct impact would unleash energy on the order of 1,200 megatons, more than 80,000 times the Hiroshima bomb. The shockwave would vaporize everything within a city-sized radius, flattening buildings and forests for tens of kilometers. In coastal regions, the ocean itself would become a weapon. Simulations show an initial wave nearly a kilometer high, with walls of water racing toward distant shores. Even hundreds of kilometers away, tsunamis could sweep inland, erasing ports and flooding entire regions. The blast alone would ignite fires, shatter glass, and send a plume of superheated debris into the stratosphere. For weeks, sunlight would dim, crops could fail, and weather patterns might shift on a global scale. Chelyabinsk and Tunguska were warnings, small rocks, local chaos. Apophis is in a different league, closer to the scale of the Chicxulub impact that ended the age of the dinosaurs. But even that comparison falls short. Chicxulub was a planet killer. Apophis is a city killer, a regional disaster with global echoes. The question is, could we stop it? In 2022, NASA's DART mission proved that a spacecraft could nudge an asteroid, Dimorphos, by a fraction of a millimetre per second. The team celebrated a 0.4% change in velocity, enough to alter the orbit of a rock less than half Apophis's size. For Apophis, the math is unforgiving. A DART-class impactor would barely budge it. Multiple missions launched years in advance would be required just to shift its path by a few hundred meters. And if time ran out, the only options left would be nuclear, an act of last resort with no guarantee of success. For now, the world's best defense is hope that the data holds and Apophis keeps its distance. But hope is not a shield. The planet remains exposed and the clock is always ticking. Within the scientific community, the numbers tell one story, but the debate refuses to die. On paper, the risk of Apophis striking Earth in 2068 has dwindled to just 1 in 256,000, a probability so small it barely registers. David Farnokia at NASA's Center for Near-Earth Object Studies describes the transformation as dramatic. The uncertainty in Apophis's orbit has collapsed from hundreds of kilometers to just a handful. Decades of radar and optical tracking have squeezed the margin of error to levels once thought impossible. Yet even as supercomputers spit out reassuring odds, a current of doubt runs beneath the surface. The problem is physics doesn't rest. Forces like the Yarkovsky effect, a gentle push from sunlight warming one side of the asteroid, can nudge Apophis's path by meters or even kilometers over the years. A single unmodelled impulse, a micrometeoroid strike, or an unexpected thermal drift could shift the asteroid's course just enough to matter. And every flyby, every new observation brings its own set of surprises. Some modelers warn that the universe doesn't care about our confidence intervals. The more precisely we measure, the more we realise how much remains unknown. So the question lingers, is the danger truly gone, or have we just learned to live with uncertainty on a cosmic solar scale? April 13th, 29. A date that lands on a Friday, the kind of coincidence that would have sent ancient priests scrambling for omens. Instead, the world's astronomers will be watching their screens, tracking a rock named for the serpent of chaos. There's a reason the story of Apophis lingers in the mind. It's not just the numbers or the physics, It's the way myth and modern anxiety wrap around each other, tightening with every new calculation. The asteroid's path is a reminder that the universe is not a clockwork of certainty, but a shifting landscape where order and chaos trade places in the dark. Some will say the danger has passed, that the odds are too small to lose sleep over. Others, haunted by the scars of Tunguska and Chelyabinsk, will keep searching for the flaw in the models, the overlooked force, the next rock waiting in the shadows. The symbolism of a close pass on Friday the 13th is impossible to ignore, a cosmic wink at human superstition, or perhaps a warning that fate cares nothing for our predictions. As Apophis sweeps past, the world will hold its breath. Not because the serpent will strike this time, but because it might not be the last. The real question isn't whether Apophis will miss, it's whether we're ready for the day something doesn't. On April 13th, 29, Apophis will pass just 31,600 kilometers from Earth, closer than many satellites. This unprecedented flyby recalls the 2.7% impact chance calculated in 2004, a figure that triggered the highest ever Torino scale alert. Scientists have since traced a narrow 600-meter-wide keyhole in space. If Apophis threads it, a future impact could be set in motion. The Chicxulub, Tunguska and Chelyabinsk events show the reality of asteroid threats. Yet even now, some details remain uncertain, including the precise effects of Earth's gravity on Apophis and the limits of current planetary defences. While current risk estimates have dropped to less than 1 in 250,000, the debate among scientists continues. What is clear is that the 29 flyby will test our ability to track, predict and prepare for cosmic hazards. With Apophis, the line between safe passage and global disaster is defined by facts, measurements, and our readiness to act on them.